All right, we're back. This is the third talk on day 2 of Angular Remote Conf 2015. This is going to be Randall. I didn't even ask how to say your last name. Randall Koutnik?
Koutnik.
Koutnik? Okay.
Yep.
The talk is Optimization Killers, Finding and Fixing the Hidden Glue Bugs. Randall is an Angular engineer at a nifty security company. He's worked with Angular for just under 2 years and is a contributor to Batarang. You should read. You should also read his blog at koutnik.com.
Yep.
And I will turn the time over. Take it away.
All right. Is it sharing my screen, or is all I'm seeing is my avatar?
It is blank.
Oh. Fun. I mean, that's the law of giving a talk, is that you will have something go wrong with your screen. So now we got that over with. Can you see it now? I just re-screen shared. Oh, cripes.
It is still blank for me.
All right. All right, I'm back. Can you reset it to?
There's your video.
Are we seeing my video? Seeing my just beautiful face.
That's right.
Good. Now let's actually get to the slides, because you didn't come here to see my face. All right.
Oh, there we go.
There we go. We have glue bugs in this nice, brilliant orange.
All right. This is the part where I shut up. Go ahead.
All right. So is everyone seeing it should say, glue bugs, and it's got all this nice orange opening slide?
There's a slight delay, so you might see a little bit of delay on the chat.
All right. Well, so I'm just going to assume everything's doing great, which is the worst thing a programmer can do. So do as I say, not as I do in that instance, and move forward. And we're going to talk about glue bugs, which is performance issues, things that are slowing your app down. Your app might be working exactly fine and all of your tests pass, but if your app is slow, it still has bugs. So first, let's do the traditional slide about me that I'm pretty sure like the Geneva Convention or something requires me to put this slide up. That's me on the left. You probably saw me with headphones and slightly more scruff earlier. You can find me on the right. A blog mentioned earlier, Twitter. I am Some Kittens on GitHub, and you have not lived until you are in an interview talking about actually someone paying you quite a lot of money to write code for them, and you have to say, my name at GitHub is Some Kittens. So, and I do a couple different things. First and foremost, I'm a contributor to Batarang. We've been working pretty hard on fixing all of those bugs and just making it the ultimate tool in Angular 1 debugging and performance tuning. There are plans and things being worked out behind the scenes for Angular 2. And that's about all I can tell you, because I know someone's going to say, what about Angular 2? And all I can tell you is I can't tell you more. And I also contribute. I'm the main owner for UI Layout, if you use that. Really nifty thing for splitting up panes. And I also have my own project called Gustav, which is not Angular, but I thought I'd mention it's all about dealing with processing streaming data. But the really important thing is the FOSS bash. AngularBuddies.com, you can go sign up right now. Don't sign up right now. Listen to my talk, because that's more important. But as soon as this is over, go to AngularBuddies.com and sign up for our Slack group. It's a chat program. And there, every month, we do something called the FOSS bash. And we have a bunch of hackers there on Angular, from people who are just starting out to crazy wizards who've been doing this for years. And everyone of all skill levels gets together and finds an open source project to hack on, close issues, find duplicates, write more test cases, improve the documentation. Just everyone kind of swarms together. It's awesome. The maintainers are there in chat just to live answer questions, so and complete PRs and things like that. It's fantastic. The next one is October 10th, and we're going to be hacking on Kent's Angular formulae. I remember Kent from yesterday. So highly encourage you to join. It's just an amazing day to get together and contribute back to Angular. So I don't know quite if we really need to ask the question, why is performance important? But there's a lot of apps out there that are good enough. You've written it, everything technically, comes back from, an AJAX request and gets put on the screen and all that. And it works, it's fine, but it's slow. And that slowness and that problem, that means there's still bugs hiding in the code. Our app is not working how it should, and that's the very definition of a bug. So you should be finding these bugs. You should be putting them in your bug tracker. You should be finding and fixing them as part of your sprint, as part of however you work as a developer. These are just as important as any other bug. One neat, if you think all your coworkers, but they don't really care about performance, find a whiteboard, go through your app, do just some performance checking, write down the numbers, and graph them on the whiteboard. And so after every day or every week, graph the next set of numbers and watch as if the performance numbers go up and it takes longer and longer to load. If people start caring more and more about performance, I found that's very effective to get people to actually care about making an app fast. So in Angular, on the front end, your app's performance is the result of multiplying two numbers together. So the sum total of your performance is how many digests you're running multiplied by how long your average digest is. And so there are different bugs that can cause either of these numbers to go up when you don't want them to. So first, let's take a second and talk about what a digest is. And what are watchers and why these cycles are happening, and that AngularJS is some real just bad pulp fantasy novel you find at the supermarket that reads, as the watchers came to the conclusion on Mount Closure, the digest cycle neared completion. Our hero, equipped with a pair of colons, knew he had only one chance to bind their deepest watcher permanently, and all this magic going on behind the scenes. So what's actually happening? Well, when we do that little double bracket on the page to say, take the value stored in this JavaScript variable and actually render it onto the page, Angular adds a watcher. That's a watcher. So it says, I need to pay attention to this value, so when it changes, I can put it on the page. And then other things that do things like that. I mean, ngbind is the same way. ngrepeat will create watchers because it says, I need to watch this value. I need to make sure that when it changes, there's something I need to change on the screen. And so behind the scenes, there's something called the digest cycle. And Angular has a long list of all of the watchers. And it goes through each one and says, have you changed? 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 And if you've ever done $scope.$watch, this is what's happening. It says, watch this value. And when it changes, run this function. And so as Angular just goes down this whole list, have you changed? Have you changed? Oh, you've changed. So I need to run that second function, and whether that second function says, all right, change some data on the page, or change some other data, or manipulate something, Angular says, all right, this cycle, this time through when I asked all of the watchers, something changed. So that something changed may have changed a value I need to watch earlier on in the cycle. So once I finish asking them, I need to start over and make sure that everything, no one has changed the next time around. So a digest cycle is when Angular goes through all of your watchers twice. And so once it gets 2 times through and it cleanly says nothing has changed, it stops. It says, all right, I don't need to do anything more. And so if you've ever had like infinite dig or something like that, the error, Angular will hit 10 times through, it says things are still changing. I think there's something wrong with your app. And so that's where that error comes from. And so what triggers the digest cycle? I found a lot of beginners to Angular don't quite understand what triggers it. And the answer I hear the most is, it's a set interval. So every 100 milliseconds, Angular is running through this, which it may seem like, especially if you have a slow app, that it takes 100 milliseconds to actually get anything updated, but that's not true. If you just let the application sit there and you're not doing anything, Angular's not running the digest cycle. It only runs it when something triggers it. So most any action you'll take within the Angular ecosystem will trigger the digest cycle. So a key down on an input that has an ng model attached to it says, all right, the user has changed something. We need to go check everything. So if I key down on an ng model and I have a watcher on the page that's connected to that ng model, I'll key down, that value will change. Angular will see, hey, you've changed. I need to update the value on the page, and then move through the rest of the cycle. ng click, any of the ng events say, all right, run whatever you've passed in, and then run the digest cycle. Timeout, interval of dollar timeout, dollar interval specifically, dollar HTTP, all of those services, when they finish, when those promises resolve or reject, Angular will then run the digest cycle. So if you make an HTTP request, as soon as it comes back and you say update the data, it'll run through again. So that is, once you start understanding that, performance becomes a lot easier because you understand, all right, well, I'm running that digest cycle and I know things are clean, so I don't need to run the digest cycle this time. Or as it's going through, have you changed, have you changed, have you changed? If that one thing has to spend a ton of time to say, I don't know if I've changed, it takes forever, that'll slow everything down because it needs to go ask all of these things that they've changed a lot. Number-wise, your whole digest cycle should run in 20 milliseconds or ideally 16. So if you can get it down to 20, you're doing pretty good. If you get down to 16, on average, you're down to 16, then you really have a performant app, and you've really gotten to that point. There's no real good rule of thumb on a number of watchers because of the way it can be triggered. I can sit there, look at your app, and have no watchers for 30 seconds, and then perform 3 actions that cause a bunch of digests. So in all of this, the standard performance caveats apply. Don't optimize prematurely. Don't say, well, this thing is slow, we should optimize it. Because often optimization makes code less readable, albeit faster. And the optimization could result in bugs because the code may be less intuitive. So a programmer may come to it and make a change and break something that they didn't understand. So optimize things where it's needed. Don't optimize just because. Same thing, measure twice, commit once. Make sure you know you found those bottlenecks. And the third point is just a repetition because this is so important. Find the bottlenecks. Find out where your app is slow. So not only is it because it makes fewer bugs, but once you found the slow parts, if I optimize something that only happens when my app first loads, the first load time is important, yes, but overall I haven't saved that much time. But if I make my digest cycle, which could run 24 times in a second because of different ways, if I increase that by just a few milliseconds, the entire app will speed up because that's happening so often. So that's great, Randall. We have lots and lots of numbers and terms and things that are important, and you tell us, we should find the bottlenecks and what the slow watchers are and things like that. How do we do that? And the answer is batarang, as I mentioned earlier. Batarang is a Chrome extension that does a lot of amazing things for you. I'd love to go into them, but this talk is about performance, including performance tools. It'll give you insight into how fast your app is running. One word of warning, Batarang is now at 0.10. Someone forked the project back at 0.4 and published it to the Chrome store as the, quote, stable version, unquote. It's still 0.4 with all of 0.4's bugs and problems. Make sure you're on the latest version of Batarang for all of this to work. So we can actually take a look. This is Virgin America's site. I'm not affiliated with any of them at all. They just use Angular. So it's a fantastic site to just test things against if I'm testing an Angular site. And we can see down here the Batarang panel. So we have performance, which is still in alpha. We're still hammering things out, but it'll give you good information. It just doesn't look very nice. And you can see the last digest cycle on this site took 55.5 milliseconds, which is slower than we'd like. And it had 1,441 watchers, which is good. The number of watchers your watcher budget, you really shouldn't be going over 2,000 on average. And we can see that on average, the cycles are actually running a bit slower than the last one. But they also have fewer watchers on average. So it's best to look at the past averages rather than one immediate digest cycle. And we can trigger more. So scrolling is triggering quite a few digest cycles here. So if you're looking at performance and you have a slow digest cycle, if we're triggering a digest cycle in every scroll event, then we'll have a slow app. Fortunately, the scrolls are well under the limit we're worried about, and they don't have that many watchers. But let's open this. You can see our number of watchers increases, and we can close that and go through. And so that's batarang. That's the general performance. This Canvas graph is from Kent C. Dodd's NG Stats, and he was generous and amazing and let us use it. And that's exactly how open source software should be. And so if you've used NG Stats, we're moving all of the features of that into batarang. So you can still use NG Stats if you want to, but batarang will have all of those features and just a nice graph showing what's going on. Now, one of the things that batarang does that NG Stats doesn't is we look at every single watcher. So I'm zoomed in a bit, so the table is gonna be a bit big. We can see the airport picker type ahead enabled is in fact our slowest watcher because it's at the top of the list. We can see that with that watcher of all the watchers is taking a third of a millisecond. So it's not that fast. I mean, sorry, it's not that slow. This is a relatively fast cycle we're looking at. And there's 55 of them. 55 times in that are have you changed, have you changed, have you changed, have you changed? 55 times the thing being asked was airport picker type ahead enabled. So you might be able to reduce that. If it's in an NG repeat, you might not be able to reduce that. But if you can make that thing faster, you're making it 55 items faster instead of, say, 6 with slide image rollover. So this is, and then way at the bottom, we took that out. We used to just display the raw data for you to peruse through, but we're getting better at displaying useful data. This is batarang and how to look into those stats. How many watchers do I have? How many cycles? You can see over here how tightly tight together the digests are appearing. So you get a lot of digest together. That's also something you can do with regards to the performance. So that's batarang. That's a general overview of performance in Angular. So I just want to check the chat real quick and see if anyone has got any questions, things like that. So I'm not David Smith. Let's see. Oh, hey, Kent is watching. Woo. Yeah, I'm pretty sure as far as the fantasy goes, that's the first Angular fan fiction I've heard. So I want to claim first on that if no one else can do that. And okay, so increase the zoom on the browser. And yeah, I will try and do that. I'm assuming you can see the actual slides, and I'll increase the zoom on batarang and the pages we'll be looking at. So cool. Glad everyone is up to date. So let's talk about bugs. All these bugs we've been talking about. I've always liked the Space Marine archetype because I have a lot of sympathy for people who just spend all day fighting endless hordes of bugs that ultimately they were responsible for creating in the first place. I just like Space Marines and 40K and all that. So let's talk about things that increase the length of your digest. So we're not caring about how many digests, but a single digest, how long does that take? And there's two things that causes that. So I guess there's three numbers that cause performance, but that wasn't as catchy. So the length of the digest is, so you have, how many watchers do you have? How many times does Angular say, have you changed, have you changed, have you changed, have you changed? And not using bind once where we can will increase the number of watchers. Using ng-hide and ng-if wrong will also increase that. And then there's longer watchers. The process saying, Angular is saying, have you changed? How long does it take to say yes or no? And again, we see ng-hide versus ng-if will also take a while to, it will also increase that time of yes or no, depending if you're using the wrong one. Stateful filters will take time to come back and say yes or no, I've changed, because it's running the filter in addition to just checking the raw value. And finally, deep watches. So if a watcher is watching, 1,000 things, it has to check all of those before it says yes or no, I've changed, and that's a single watcher. So I know you folks are all incredibly, crazy good hackers. So let's look at some code. Let's look at some actual real life examples. So here I have just an ng repeat, seen it a million times, with some data inside that fakers kindly generated for me. And we can see in batarang the fact that we've got 303 watchers, and a digest cycle took 713 milliseconds, which is not fast. We want that to be faster. And so the reason I have that is because we can look at the code. You can look at that. You can see I have an ng repeat, and that's going to create a watcher because it's going to watch bind once demo people. And then I've got person ID, person name, person email, and person about activity. And each one of these is a watcher. So every time something happens that triggers a digest cycle, it's going to say, all right, for everything, for every person we're looking at, check the ID, check the name, check the email, check the activity. And some of these are probably not going to change. So we can just, instead of saying every time, check their name, we can assume that at least in real time, their names aren't going to change. So we can add 2 colons to the beginning of the watcher. And what that tells Angular is the first time you see a value that isn't falsy for this particular person.name, just put that on the page and then don't look at it anymore. Remove it from the watcher. So if person.name changes later, it won't update on the page. But we know our apps and we say person.name isn't going to change. So we can remove that from the watchers, and we can do that for all of these. And then go back to the full view. And then wait for it to render, and then we can see it still have 303 watchers because the watcher counted the first time when it checked, and now we need to, another fantastic feature of batarang, if you select an element in the elements panel, it sets the global value $scope to the scope of that element. So you can say scope, actually tell that scope, digest. Go ahead and digest, go through your whole thing. Go back to Angular, and we've gone from 303 to 1, which is fantastic. And that's the power of bind once. And we've also found a pluralization bug in batarang. Whoops, that should say 1 watcher, not 1 watchers. So, and that's the power of bind once. If you ever have any sort of data, once this is here, it's not going to change, bind once. That's also a neat way to tell other developers who look at your code. They can go, oh, this value isn't going to change in the future. And then they can note that, and it's useful for them to know as well. So we can close that one. So let's talk about, and then we've got this kind of double feature about ng-hide versus ng-if. And so pull that JS bin up. So I've got just this boring old ng-if, ng-show. And so if we use ng-if, show the data, we can see there's only 14 watchers. If we use ng-show, we have 107. What happened? So we need to actually dig into what's happening behind the scenes for ng-if versus ng-show. What ng-if will do is, if it is given a falsy value, it will remove the element it's attached to, all of the child elements from the DOM completely. They're gone. What that means is all of the watchers in those elements are also gone. So when we don't need to worry about that data, we aren't going to watch it. There's one caveat there. As soon as you remove them from the DOM and add them again, if you've attached many event listeners to those elements, the element was removed, so the listener won't work when it comes back to the DOM. So that's just a little bug that if you're using ngIf, you probably will hit at some point. With ngShow, on the other hand, it's just a CSS class. And that CSS class does display none, and I'm sorry, Chuck, it's display none important. So it will just completely hide whatever you're attached to. So the elements are still in the DOM, the events are still there, the watchers are still there. The advantage of ngShow is that it's all it's doing is adding or removing a class. DOM operations are one of the slowest things you can do on the front end. So if you're ngIfing a lot of elements, it will be slow if it's flipping back and forth. So let's actually see that in action. Let's go back to ngIf, and I'll click show data. And you can actually see that, hopefully, in lag and skip, you can see that there's a measurable pause. There's, in fact, an 822 millisecond pause as Angular had to go attach all of these elements to the DOM. And as soon as we uncheck it, removing elements is a lot faster. But adding them to the DOM takes time. But when we uncheck it, we have 6 watchers instead of, check it, 316. So it's a huge benefit for us in that we don't need to worry about the data there. And if we flip over to ngShow, we can see that toggling the data is pretty much instantaneous. It's less than a millisecond. But we have 115 watchers, and we uncheck it, and we still have 115 watchers. So even though we don't see that data, Angular is still watching it. Angular is still checking all of those watchers inside that data. So it's up to you. And that's why ngIf and ngHide make the list twice. Because you can accidentally have too many watchers if you're using ngHide instead of ngIf. And you can have longer watchers if you're using ngIf when you really should be using ngHide. ngShow is essentially a negated ngHide. So ngShow will also just toggle that CSS class. So if you're wondering about that. So let me check the chat again. It's increasing the zoom. I think I did that. I can do it again. Yeah, the batarang has 2.5 stars because last December there was an update that was pushed that actually broke Angular apps. So if you had batarang installed, your Angular app wouldn't work. And a lot of people got mad about that. That actually is why I joined batarang, because I got mad about that. So I said, how can I help? And Brian Ford says, here's a bunch of bugs. And so I fixed them, and that's why I ended up being a full-on maintainer of batarang. So if you get mad at an open source project, just instead of saying, I hate this is dumb, say, how can I help? And the maintainers will love you because maintainers are always overworked. So if you install batarang, you like it, review it and give it stars. So and yeah, and that scope in the console is probably probably the most used feature of batarang over anything. So let's move on to stateful filters and deep watches. Things that where a single watcher will take longer than it needs. So whoop, didn't mean to click that. I actually have that preloaded over here. Not that one. Preloaded over here. And what's a stateful filter? Let's look at the code. So Angular is pretty smart. So I have this sign up time. And thanks to a quote unquote bug in the code, that sign up time might be in the future because this is a real thing that happens when the server time is out of sync with the computer time. So you need to check, see, oh, you signed up a minute from now. And so we've added this filter time ago that if it's a time in the future, we'll just say it's just about now. It's close enough, close enough. and then we'll give the exact seconds ago, or just use moment to give us minutes beyond that. Now, like I said, Angular is smart. It's trying to do a lot of optimization for us. And one of the things it will do is, if person.signup hasn't changed, then it will not run time ago. It says, why should I run this filter again? We already know that the value hasn't changed. Except in situations like this, when, well, the value of the signup date hasn't changed. The actual thing we want to display has. So what we do is we say, all right, the function we're returning, we're going to set a property on it, $stateful. Set that to true. All right, this is a stateful filter. And what that means is, even if person.signup hasn't changed, Angular still needs to run the filter. And we can see when I just run a digest, you can see that the values are increasing despite the fact that the signup time hasn't changed. And this is really nice. It's a useful feature of Angular that allows the most performant thing to happen and allows us to override that if we want to override that and use that. The problem is specs change. Things get different. There's people change how values. We may fix that server bug or something like that. And you may have stateful filters still in your code base that don't need to be stateful anymore, that are causing slower digest cycles. And if you're looking at the code here, I don't know if you can quite see it. Let's try and zoom in a bit. This is a horrendously non-performant filter. I had a lot of fun writing just a deliberately slow filter. So we actually run this, pull a batarang, and actually run this. We can see the digest cycles are taking quite a while. So even though time ago I tried to write it slow, I didn't write it nearly slow enough. I'm really bad at writing slow code. So what's your greatest weakness? And so what we get is our digest cycle should be on the order of a millisecond, maybe a millisecond and a half. But because of this stateful filter, we're getting a much slower digest, even though 13 milliseconds isn't actually that slow. It's still allows us to run at 60 frames per second. But either improving the speed of that stateful filter, creating fewer data objects, using some caching, things like that, will help speed our application up, because that filter is going to be run every time along with the digest cycle. We don't get that guarantee of not running it if the value hasn't changed. Or two, we could figure out a way to restructure how things work so that the filter does not need to be stateful anymore. So always be on the lookout. If the filter is stateful, say, does this really need to be stateful? And if it does, you can still try and make it as fast as possible. But if it doesn't, then there you go. That's something that'll make your application run a lot faster. So we can close tabs. And so finally, on the longer watchers things are deep watches. So we can see here we have 10,000 things. All we want to do is know the number of things we have. So you have 10,000 here. And the last digest cycle took 1.3 seconds. So that's slow, 1.3 seconds and 6 watchers. So that's taking ages. Batarang is not very good yet at detecting deep watch problems. So it'll still tell us that our deep watch here is running quote unquote fast, but we know it's not because we've got this bigger number up here. So if you've got a deep watch and you've got a slow, it might be a little harder to pull out. That is a known bug with Batarang. So we can actually add more things and run the digest cycle again. You can just see how long it takes for that button to be unclicked. How much that deep watcher is costing us in terms of performance. So now digest cycle is 4.3 seconds. So again, let's look at the code. I will be sharing the slides. I'll be sharing the code. You'll be able to see everything as soon as I'm done with this. And so we've got just innocuous, innocent-looking array where we push 10,000 objects onto it. And then every time I click that button, I add another 10,000 objects. And then we've got this really, it's only 3 lines. It shouldn't be that slow. Watcher here, and that's watching that array. And it's watching that array, and it's just logging the length so that this function doesn't get optimized out. And then that third parameter, true, says, instead of just watching vowels, just watching the array, watch that array, watch all the properties of that array, watch all the contents of that array, and continue to do so. So for every array or object inside that, watch all the properties, watch all the contents, watch all the way down. Which, even though this is quote unquote one watcher, it's going to act like it is lots of watchers, depending on what you're actually watching at that point. So most times when you're doing a deep watch, the data you want is not, you don't need deep watching. Here, all we need is the length of values. So instead of watching vowels, we can watch vowels.length. And that's not a deep watcher, that's a single watcher. That's so no matter how big vowels is, it's a single property check. And that's it. So it's much, much faster. Alternatively, we can use watch collection, and that will watch only the first layer of our thing. It won't recursively go down, go down the list and say, all right, well, this array contains an object which contains an array which contains another array which contains 17 objects. It only looks at the first layer. So if you have a deep watch, you need to sit down and think really, really hard. Is this necessary? Do we really need to be doing all this processing? This is one of the most insidious glue bugs out there. So that's it for things that make our digest itself, just a single digest, take longer. Let me check the comments and questions again. So you guys can hear my phone going off. So I remember to actually, I'm wearing headphones and I muted everything, but forgot about actual physical vibrations. All right, so cool. So do not be afraid to ask questions, things like that. So I can cover them in breaks or at the end of the talk. So let's talk about things that increase the number of digests we have going on. So we may have sat down and said, all right, well, we've got a relatively performant digest cycle, but we're calling it an absurd number of times. And so let's first take a look at ng events. This is a blue box. On this blue box is the directive, the core directive, ng mouse move. So what have we learned? We've learned that the digest is triggered whenever any of the ng events happen. And so if I try to mouse move on this, you can see down below it says there have been 0 digests. As soon as I try to mouse move across this, I get a digest for every mouse move event. And so the general recommendation is to never use ng mouse move at all. Never use these events that can trigger or looking at scroll, ng scroll, things like that. We saw that on Virgin America's site where whenever I scrolled, it was triggering a digest. And so, I mean, they're fast digests because all they're doing is incrementing a number, but we're getting an inordinate amount of digests. So even with this many digests, even running at that optimal 16 millisecond, 60 FPS digest, we might be running so many digests. We're getting more than 60 a second that our app is still slow. It's still, all those digests queue up. And then the user has to sit there and wait for all of the digests to finish. It's because if we try to start it, we'll have to wait for all those digests to finish before they can do anything. And remember, it's all these, if you have a slower app, one that isn't, nice and finely tuned, then all these digests are going to take ages. I worked on an app that had a digest cycle of a little over a second on average, and they actually abused the next thing we're going to talk about. So they don't worry a lot about NG events, and if you need to do something on one of those events, there's no shame in creating a directive, attaching an event listener to that element with JQLite or jQuery, and not triggering the digest cycle for performance. So you know, a lot of people are like, oh, don't use jQuery. In that instance, it's perfectly fine usage, just to kind of allow that one particular event to be outside of the digest cycle, because it'll be triggered so much. So, and then one other, the final glue bug we're going to look at is calling apply ourselves. Beginning of talk, I mentioned, you know, a lot of people don't really understand what's happening in the digest cycle behind the scenes. And hopefully all of you do, and you can all go out and say, I know the digest cycle works, and tell everyone else. And so, and some people say, yeah, it runs in set timeout or set interval, something like that. Others try, and especially people who try to convert jQuery apps to Angular and just copy paste a lot of jQuery code, and then things don't update because jQuery is doing all the event listening and things like that. And so Angular never knows to run the digest cycle, and then they just scatter applies everywhere or digests to manually run them instead of just using ng-click. And then, so first off, we're running a lot of digest cycles we may not need to run. And second off, if we have times when Angular is running the digest cycle, we still have that pattern in our head of, I need to call the digest cycle. And so we're calling it twice. And so we have just a random number that we can do to do that. And if you're paying attention to batarang, I don't know how well it's going to come over. You can just barely see that there's several digest cycles being run every time I click that button. So let's look at the code. This actually is pulled from production code that does not run anymore. But so here we have, because if you try to call apply when a digest cycle is already running, you get a nice big fat error in the console, and you don't want that. So a lot of times beginner programmers, there's nothing wrong with being a beginner. A lot of times beginner programmers will write some sort of their own apply function to trigger apply without interrupting the digest cycle, not knowing that if they're calling apply and the digest cycle is already running, they don't need to call it again. It's the data is going to get where it needs to be. And so oftentimes you see patterns like this, where, okay, so we've got an ng-click on the left. So it's give me random. And that's a function. So we know ng-click is an Angular event. It will run the digest cycle for every click. So we know we've got one digest already done. And then we've got this root scope super apply. And let's take a look at that. So that takes a callback. And it runs timeout with no second parameter. So what that's going to do is how timeout works. This is really clever, but unfortunately not clever in a performant way. Timeout, if there's a digest, when timeout completes, if there's a digest running, it'll wait until that finishes. Or sorry, no. If timeout is called, it will wait until the current digest cycle completes before actually running its contents. So right now we're in a digest cycle because of that ng-click. So we say the timeout. So immediately after this digest cycle completes, timeout will run this and then run another digest cycle. So here we've got the callback, which is that function that sets amRandom to math.random. And we're calling, we really want apply to happen. We really want this digest cycle to work. And so that's going to run the digest cycle. And as soon as the digest cycle, so as soon as the ng-click digest cycle is finished, we'll run this and run a second digest cycle. And as soon as this callback is finished inside timeout, it will again run the digest cycle. So we're running the digest cycle 3 times when we should just be depending on Angular to do it for us. This is why you hear so much people saying, stay in the Angular ecosystem. Don't blend Angular with mountains of jQuery or things like that. Angular should be, you should run an Angular app, and Angular should be in charge. Because when everything's tied into the digest cycle, everything works really well. But if we try to kind of bolt our own stuff on top of it and run digests sometimes, things like that, then we're slowing our app down for no good reason. So in this case, the easy answer, don't do that. Just understand how the digest cycle works, understand how the digest cycle is triggered, and let Angular do its thing. This is something Angular is this is the core heart of Angular, and in Angular 2, it's going to be even more performant. They're getting even better at writing core Angular so that the browser itself can predict what's going to happen. It's very complicated C stuff. I don't understand it very well either, but so that the browser can actually optimize going through the digest cycle, so we get that even faster going through the digest cycle. And also I can say, I can have bind, instead of bind once, I can have bind, and I will tell you when it changes. So we have a watcher, we can have a whole chunk of our app that we say, don't even worry about that. I will tell you when that changes. And when it changes, it'll run the digest cycle for that section, but otherwise it won't. So there's a lot of really cool performance stuff in Angular 2 regarding how that core digest cycle works. It'll be a little more complicated, but there's so much more. This estimate is 3 to 10 times faster digest cycles, which is fantastic. So I'm really looking forward to doing that. But this is Angular 1. This is using batarang to kind of dig out all of these glue bugs. So that is it for my main presentation. That's all the glue bugs I wanted to go through. If anyone has any questions that they've asked or topics, so.
All right. Do you want me to moderate this a little bit? Read you the questions?
Yeah. So I'm looking at the chat right now. So we got one here about not using ng repeat and people writing their own ng repeats. I don't know if I've ever seen an ng repeat being used. Someone trying to write their own ng repeat. You can actually bind once on an ng repeat. It's just the double colon comes before, repeat, ng repeat item in items, put the double colon before items, and that will bind once the ng repeat. So it'll do its repeat, and then it won't touch the data again. Depending on how you want to use it, they may be great. You may just have a array of options, and the options won't change, and so you can bind once in the array, and then the contents won't be bound once. As far as making sure ng repeat. One other thing about ng repeat is track by is fantastic. Track by will allow the watcher to, if things change, to go faster. What time am I at? Oh, I've got a little bit of time. We can do a little bit of track by. But first, we have a couple questions coming in. It's good. Good. Curious people. So about ng repeat, I'll get back to track by if I can. So without forcing an apply, it's okay to do timeout. Yes, timeout's fantastic. And you should use $timeout instead of set timeout, because I can do $timeout and say, do this thing in a second, a second from now or 10 seconds from now. Same with $interval, and it's supposed to run the digest cycle. That's the point.
Can you read the whole question?
Okay, the full question. Timeout function. So without forcing a $apply, it's okay to do $timeout, right? So you can avoid problems with UI responsiveness. Absolutely correct. If I say with timeout, I want to do something a second in the future, once that $timeout completes, it should run the digest cycle, because you may have changed things inside that callback function. $timeout is not the problem at all. Using $timeout to trigger a digest cycle, it's not the purpose of $timeout. When you already have a digest cycle running, that is the problem. So it's a very, very specific usage. I have seen in rare cases people needing to run something immediately after the first digest of the page has completed. And a lot of times what that is for is I've used that. That particular hack when I was trying to do benchmarking and build things without batarang for an on-page demo. So you can actually see the number of watches and actually bind the number of watchers onto the page. And so I needed to run the code that checked the number of watchers. It didn't work in the first digest because none of the watchers had been applied yet. So I needed to run the code that checked the number of watchers immediately after the first digest. And so I did abuse timeout a little bit there. So I'm hoping that's answering your question. So all right. We have one common pattern we have is a series of directives that have an ID two-way bound. The directive fires off API based on that value using $watch. Is there a better way to do this? All right, so I'm guessing, Sam, that what you're doing, that firing off to the API is just a XHR call using the $HTTP service. And so with an ID two-way bound, and so the directive itself is making that ID call. I don't know the full extent of your app, but in that situation, I don't really like injecting $HTTP into controller and into directives because I like having services. What that means is anytime that ID changes, you're going to fire off a new request. And so if I would do some sort of fetch something by ID service, and in that service you could cache the result values. I don't know what data you've got, but if the data isn't going to be changing immediately, you can use that service to cache the values from the results. So if that watcher fires, something changes, runs through the digest cycle, it sees that the ID is different. It will make it can run against the service, and you can return synchronously, which actually will slow down your digest cycle because you're turning synchronously instead of firing off another AJAX request. But what that means is every time HTTP comes back, it's going to fire off a digest cycle. So if you fire off 18 of them, and then you get 18 requests back, well, you get, what, 6 at a time because of HTTP 1.1, but then you'll have 18 digest cycles. So if you cache them and return synchronously, that one digest cycle, one watcher might be a little bit slower. It's a property access. It's not going to be that much slower. I mean, if that adds in another 1/10 of a millisecond, I would be shocked. Browsers these days are so fast. But then you avoid having so many requests come back and running digest cycles from those requests coming back. And you avoid making requests. The user gets their data faster. One other thing you can do is there's an HTTP provider. You can do use apply async or something like that. And then what that will do is if it gets 18 requests back, as each one comes back, if there's a digest cycle currently running, it'll just push that one onto the current digest cycle instead of running a new one. And you can actually do this manually with scope.$eval async, which is the way of saying, if there isn't a digest cycle running, run a new one. But if there is one running, I just want to hop onto it. I don't need a whole new one. I just want to hop onto the current one. And so eval async can be really neat in terms of performance. If you end up in a situation where you end up having to call apply yourself a lot, just call eval async instead. You also won't throw errors if the digest is already running. As well as you can say, if I know I'm going to get a lot of HTTP requests back at this in a short amount of time, you can say just use that on HTTP itself. So does that answer your question? All right. So I'm not seeing any new questions.
Got about 5 minutes left.
So I've got about 5 minutes left. Track by. Let's talk about track by real quick. I don't have any slides or demos for this. Yes, I do. I have a architect.com/Angular optimizations. You can see these and some others in action. So bind lunch, we know that. With track by, let's zoom in. Cool, glad I could help, Sam. What track by does, whenever I do an ng repeat, and the array I have has a non-primitive value, and the array has subarrays, the array has objects inside of it. The Angular will add a key to that item, a $$ hash key, if you've ever found it in the inspector, things like that. And so that's how Angular identifies the object. So if you add a new thing onto the array, it knows that that first thing already has a $$ hash key, and it knows it's already there. It should be there. We can override that. We can say, instead of tracking by $ hash key, track by my own ID. So if I'm getting a list of users from a database, a relational database, or no, Mongo, any sort of database that has an ID, I already have an ID attached to that data. I can say, all right, Angular, track by this ID instead. It has to be unique, obviously. So if you have a unique ID attached to your data, tell Angular track by it. Why? Well, first of all, it's using data that's already there instead of creating new data, but that's not what slows it down. What slows it down here is when we want to change things. So if I have an array of data that I just got from my database, list of users, the users have an ID. If I have a second array, a longer one with new users attached to it, but the old users are there as well, and I overwrite my first array with that second array, I've overwritten all of the $$ hash keys. Angular thinks it has new data. It's the same data with additional things attached at the end. And so with track by, Angular will say, oh, I've got an entirely new array with new objects, but that object has the same ID. And so, it will not recreate the DOM elements. It will not. So when it goes to the ng repeat, it says, I already have this on the page. I don't need to recreate all of that there. I already know this is a unique thing. Just put it there. And so we have the untracked things here. And I don't know if you can see on this, but there's a slight delay in switching without track by. And with track by, it's much faster. So that's another neat performance trick you can do, is using track by. If you have data from a database, I can virtually guarantee you that it has an ID there. So using track by is just an absolute gimme in that situation, unless you have non-unique IDs in your database, and then you have bigger problems than I can solve. So I know track by, someone asked about that, or I rambled off into that. So anything else?
No, I think we're good.
All right. Well, hopefully someone out there learned something. I have one last slide that I'd like to give, and that is, you hopefully learned something here, and hopefully learned a lot here. And if you could take what you learned here, if you took notes or something like that, I'll post slides. Find someone else who doesn't know this and teach them. You will learn more. They will learn more. Just find another developer at your company or something like that. Pin them down and say, I learned all this cool stuff. And teach them everything you learned from this conference. And that's just my final request for all of you. And with that, Randall out.
All right, thank you, Randall. We're gonna switch over and hear from Jafar Hussain. So give me a minute to get everything moved, and then we'll jump on that.